Hey guys, it's Mr. C here, and in this video I'm going to show you how to derive the library function called the square function. First of all, it's called the square function because if you look at how we operate on the inputs, any value of x that we choose to plug into this function is going to be squared. That's actually where I'd like to start with writing things down, is figuring out what the outputs of this function is going to be with the given inputs -2, -1, 0, 1, and 2. Alright, so to figure out the outputs or the y values corresponding to these x values, let's take -2 to start and square it, and of course you get +4. So one point on this graph is going to be -2, 4, and you can go ahead and plot that right now. So -2, 4. Plugging -1 in, we'd have to square -1 to get +1, and we get another point on our graph, -1, 1. 0 plugged in gives us 0 squared, which gives us 0, and so we get a point on the graph at the origin. And then plugging 1 and 2 in would give us the outputs of 1 and 4. So two other points on this graph are going to be 1, 1 and 2, 4. Now, of course, you could use more negative x values, more positive x values, and you could even start to include some decimals in here, such as 1.5, so on and so forth. Of course, the more points you have, the more accurate your graph is going to look. But having these points right here is fairly good enough to help us infer the rest of the graph. So what I'm going to do is start connecting these points that we just plotted, and I'm going to extend beyond the first and last points that we plotted. And this kind of graph is called a parabola, as you may already know. So that is what the graph of the square function looks like. Now let's go ahead and discuss some details regarding it. First thing is the domain. A couple of ways you can tackle this. I think the easiest way is to look at the equation f of x equals x squared. Nowhere in this equation can you divide by 0 nor take the square root of a negative, fourth root of a negative, so on and so forth. Since we don't have to worry about those two guys, the domain is going to be all real numbers or -infinity to +infinity. In looking at the graph, it's fully connected and spreads out horizontally indefinitely. So in order for that to happen, you'd have to use all the values from the x-axis to create the graph and make it have that effect. So kind of a visual justification of all real numbers. As for the range, there is a smallest y value present on the graph, and that smallest y value is 0, and it's going to be included, so bracket 0. And because either half of the graph is shooting up to +infinity, all the y values starting at 0 and going up to +infinity are being used to produce the graph. So 0 included, comma, infinity. Now, to answer whether or not this is even or odd, we can do a visual approach, and we can also do an analytic approach. You'll notice, all things considered, my shaky hand drawing it, this graph does have y-axis symmetry. And because of that, this would be an even function. So all even functions have y-axis symmetry. Alright, for an analytic approach, what I'd like to do is compare a few expressions. Let's first write a little workspace column for f of x, and all I'm going to do is simply write down the original version of the function, x squared. Now let's make a column for f of -x. So this is the expression we'd get if we plug -x into x squared, which of course we'll start writing as -x quantity squared. Simplifying that gives us x squared. And you can see just based on these two columns that f of x is equal to f of -x. And by definition, when we have that going, f of x would be an even function. Now just for sake of completeness, if we were to make a workspace column for -f of x, we'd have to multiply the original function by -1, and multiplying x squared by -1 gives us -x squared. Alright, and -x squared isn't equal to any of the first two expressions we got in the first two columns. So another reason why the function is even. As for increasing or decreasing, this graph does both. If you trace your finger from left to right along the graph, it starts out by decreasing. And the x values that this happens on are from -infinity all the way up to 0. The rest of the graph is increasing. In other words, the x values that cause the second half of the graph to go the way it goes, or increase, those x values would be from 0 to positive infinity. And those are all the deets on the square function. Of course, if you have any questions, feel free to let me know. Otherwise, thank you.